In the name of Allah, most gracious, most merciful, I thank you all for attending this presentation. This is an overview of my presentation. I'll talk about the importance of the subject. Then I will focus on stress corrosion cracking as a main cause of pipe failure. After that, I will discuss or elaborate on the relation between stress corrosion cracking and cathodic protection. Then the coating defect severity. I'll put a sequence, the most severe to the least severe defect. Then I'll talk about cathodic protection shielding, define it and how important it is. Then I will also talk about cathodic disbondment. Then I will discuss the regulation change. And finally, I will talk about mesh-back tape. This is a study carried in southern part of Mexico for 10 years for a gas pipeline. And in this study, they observed that 2/3 of the failures are caused by external pipe corrosion. So I'm sorry to say that most of these UT detection are only finding the internal corrosion, which is very minor, minimal. The 2/3 are from external corrosion, and internal is only 10%, the yellow one. This is another study in Germany for 5 years, and they observed that what was the pointer? The pointer.
Works better.
Anyhow, this is they observed that most of the failures are caused at pipe joint. So if we combined these two studies together, we come to a conclusion that the girth weld external protection is the vital part of your project, which doesn't even cost 1% of the total project cost. As I said, stress corrosion cracking is the most important corrosion cause that make pipe fails, mainly because it is catastrophic and unpredictable. So you might have a failure in your pipe system in 2 or 3 years from starting the operation. The main cause of stress corrosion cracking is the availability of CO2 in your soil. There are 2 types of stress corrosion cracking. High pH stress corrosion cracking, where the pH is above 8. And in this type of failure, the CP current causes the pH of the electrolyte beneath this bonded coating to increase. This increase in pH makes the carbon dioxide readily dissolves in the substrate surface. Also, excessive CP current causes cathodic disbondment, susceptible material to disbond. If you all know what is cathodic disbondment, if you put two layers together and adhere them together, because they are made of different material, if you pass a current through them, there will be a magnetic field that causes a repulsion between these 2 layers. This repulsion depends on two issues. One is how much these materials are electrical resistant. Second, the adhesion between these 2 layers. So to minimize cathodic disbondment, we need to use materials that are not electrical isolated, has high resistance of electrical resistance, and to have a very strong adhesion between these 2. The second type is near neutral pH stress corrosion cracking, where the pH is less than 8. In this type of corrosion, mainly it is inadequate CP goes to the steel substrate. So if you have either desponded coating or the CP is malfunction, you will have this type of stress corrosion cracking. FBE known to be conduct CP because its electrical resistivity is very low. So if there is no holiday, FBE will not cause corrosion, will not cause shielding of the Cathodic protection. Whereas all polyolefin tapes do shield CP because their electrical resistivity is very high. Do you know, for example, the HSS heat shrink sleeve are tested at 25 kV? For example, stress corrosion cracking will not occur beneath an intact coating. So good adhesion will prevent shielding of CP. Then tinting at overlap in polyolefin, you can see the picture where you have a tint because of the tape. These tinting are a location where water accumulates, humidity increase, and electrical resistivity increases also. 73% of near neutral stress corrosion cracking are occurred with the polyolefin tapes. 73%. 2/3 of the failures, 3/4 of the failures that we get are from using polyolefin tapes, including BE, PP, PVC tapes, tapes that are outer wrapped by PVC, all are included in this. So to eliminate the effect of, to make the coating more effective, we need to resist disbondment by good adhesion, by using coating that are less electrical resistance. Second, to encourage or support the CP current coating, what's called fail-safe, which I will talk about, and then to the quality of surface preparation. These are the list of the severity of coating defects. We used to think that water permeation is the main cause of corrosion, which is not actually. The main cause of stress corrosion cracking in general and localized corrosion is disbondment of CP shielding. Second is holidays. Third is disbondment of coating that give little of CP passage. Then blustering, loss of adhesion, which is very important, loss of cohesion. Then last is water permeation and air permeation. And by the way, all of what I'm talking is, I took from articles that I can provide you with. Now, what we mean by cathodic protection compatible? We mean that if the coating fail, it will allow the current of the CP to go through. If it protect or prevent or shield the cathodic protection, there is no use then to use the cathodic protection. An example of fail-safe material is FBE. This is a first generation of fusion bonded epoxy, where, as you can see, it is very poor type, a lot of blusters. Nevertheless, there is no corrosion. It's all black, magnetite, no trace of corrosion. Why is that? Because FBE doesn't shield your cathodic protection. Second is to have a coating with a minimal cathodic disbondment. How to get that? First, to use a coating that has low electrical resistivity. Second is to have a very strong adhesion. Now to the regulation. These regulation I took copy-paste from their website. In 2007, since 15 years, they in the United States recognized the problem. and they stated very strict regulation on this. For example, NACE are saying material that create electrical shielding should not be used on pipeline, period. They even created a task group to study the consequences of coating failure as related to interaction with cathodic protection. Code of Federal Regulation in the United States, and also 2008, they put these statements. Coating material must have properties which are compatible with supplement of cathodic protection. The pipe must be protected against external corrosion by a non-shielding coating. There is no single polyfin tape allowed in United States or Canada for maximum allowable operating pressure pipeline. They are not operating anymore there. They only operate at our area. The pipe must be protected against external corrosion by a non-shielding coating. Now, the Pipeline and Hazardous Material Safety Administration, FAMSA, in 2010, they put this rule which stopped all polyfin tapes from, or heat shrink sleeve from installed in pipeline in North America. The alternative maximum allowable operating pressure rule requires the use of non-shielding coating. A non-shielding coating is a coating that allows cathodic protection current to pass through the coating and along the outside surface of the pipe, which an oxygen barrier, even if coating has disbonded from the pipe surface. That means if the coating disbonded, the current should go through. You shouldn't put a system with two defense lines where the first, if the first defense line failed, it prevents the second line from operating. And this is what's happening with polyfin. Polyfin, by the way, it's not only these, also the PVC outer wrapped, what you call it, viscoelastic material is included in this. Then they give an example of shielding material. Some example of, gentlemen, I copy-paste. I didn't write this. Some example of shielding coating are polyfin tape, shrink sleeves, coal tar mastics, asphalt, etc. This is also from an article I took. So in this article, they define which material are shielding, which material non-shielding, and which material are semi-shielding. Shielding material, 3-layer polyolefin, 3-layer polyethylene included in this also, heat shrink sleeve, solid, film, packed tapes. They are all operates only in my country. Non-shielding, FBE, and mesh-packed tape only. These are the only two tapes or protection coating that doesn't shield cathodic protection. Semi or partially non-shielding, asphalt, enamel, coal tar enamel, and 2 epoxy coating. What is mesh-packed tape? Mesh-packed tape is a composite of bitumen plus continuous filament of thermoplastic fiber that gives reinforcement. So this film of bitumen doesn't sag like viscoelastic material because it is reinforced by thermoplastic. More than that, it has a wavy meshed polypropylene reinforcement. This wavy shape allows for the following. First of all, cathodic CP current first of all, it allows the cathodic protection to pass through the current. Second, it is reinforcement because this polypropylene is twice as strong as polyethylene. Second, because it is mesh wavy, the crack doesn't propagate. Third, it extrude compound in overlap. Now, to install this type of tape, we use a machine wrapping. That machine wrapping assure the force of tension that forces the bitumen to come out from the mesh and adheres to its secondary layer. So it is compound to compound adhesion. It becomes one piece. It becomes one sleeve. It's not a tape. It's not a tape at all. Here you have a hydrogen evolution take place that prove, first of all, a stress corrosion protection prevention, and second, fail-safe property. This is a third-party inspection laboratory who tested the material, KTA Tator in Canada, and they assured a minimum of 3 Newton per millimeter adhesion on steel at 23 degrees. Gentlemen, this is the strongest tape available in the market. There is no other tape that can provide you with 3. By the way, this is a very conservative number. Myself, I tested 5 Newton per millimeter, and I can show you on video in projects here in Saudi. It can reach 7 Newton per millimeter. What we do, just as being conservative, we are saying 3 Newton per millimeter. What does 3 Newton per millimeter means? It means 3 times the European standard, which asks for 1 Newton per millimeter at steel at 23 degrees. It also 3 Newton per millimeter on FBE, which you cannot at all get it from other coating. So what we said before, to conclude, to have an unshielding or to prevent your pipeline from stress corrosion cracking, you need 2 factors. First, CP, non-shielding. Second, very strong adhesion to prevent cathodic disbondment. And you get it from this only mesh-packed tape. So what is mesh-packed tape? It's a proven non-shielding property, excellent soil stress resistance because of strong adhesion, superior adhesion, compatible with all coating system, self-healing property, non-heat required, minimum surface preparation, only 1 inch overlap, so save of money, and finally it is very simple to apply. You need a manual wrapping machine that maintain a strong adhesion. If it is a very long pipeline for rehabilitation, we can use a machine operated wrapping machine. Thank you. This is me teaching DEO group how to do bend in Sadara project when I was younger, maybe 10 years before. Thank you.
You are still younger.
Thank you.
All right, any question for Mr. Hamad?
Can I ask a question? How many of you are customers? I mean Aramco, SWCC, Witico, واحد. One? Okay, good. Because I am very upset really. Yesterday I had a presentation there, no customer, all suppliers. And it's really very upsetting. Thank you.
All right.